Okay, so I will explain to you and everyone else who is watching what the problem is in your logic. So first of all, you said you can flip. Here you said, let's grab a male and put them into the box. Then you have an assistant of a random person in the box. Blah, blah, blah. That actually means you say, when someone says, I have 2 children, then you say, I will put 1 child in a box, and then after I confirmed it's a boy, then I will put another child in a box. And that's just not the situation we are in. We have the situation, I have 2 children, and that means we already have flipped the coins. I have pointed this out multiple times, but you just don't understand it. That's not the same situation. And here, I'm explaining to you every possible way the problem can be interpreted and the solution to it without using your flawed logic and the wrong experiment. So, first of all, the situation, I encounter a random boy with his parents knowing that they have 2 children. That's the first situation I'm explaining, and I'm now stating the second situation and the third situation, and after that I'm explaining each one. So, the situation 2 is I ask the parent, do you have at least 1 boy? So, this is the second situation, and that was what I was referring to you in the comments all along, and which I stated relatively early. So, the third situation is, the parents tell me a random true fact. What I mean by this is, the parents of 2 children can tell me, I have at least 1 boy, or they can tell me, I have at least 1 girl. And they will decide it, what they tell you. You get it that far? So, let me explain situation 1. Of course, I randomly pick someone from the 4 possible pairs. So, we have 4 girls and 4 boys, and 2 boys with a brother. Because BB has 2 boys, obviously. So, therefore, the chance is 1/2 that a boy I randomly pick from a 2-child family has a brother. Okay. But that's not the situation we are in, because no one ever said that you randomly pick a boy or you randomly encounter a boy in the wild with his parents. That's not what was described at all. So, situation 2. When I ask the parent, I can obviously exclude GG pairs, and therefore BB is one of 3 possible pairs, which are BB, BG, and GB pairs. So, 1 time, 2 boys, and 2 times mixed genders. Therefore, it's 1/3, as the video already explained. And I try to explain to you too, and you also acknowledge this in the middle of our conversation. So, you still keep trying to say, when we don't make this exclusion, then we must arrive to 1/2 with the experiment. I have flipped 1 coin, and it shows heads, and then I flip another coin, because then that's the only way we arrive at 1/2. And you are wrong, and I said it to you already, and I will say to you again here. So, situation 3, it's still not what you said. It's not what you said. Case 1 is, we have a parent that has a boy-girl or girl-boy pair, right? So, the parent selects girl or boy at 50% each, because the parent can tell you, I have at least 1 boy or I have at least 1 girl. So, the second case is, they have both boys or both girls, so it's 100% likely they will say, I have at least 1 boy, and there it's 100% likely to say, I have at least 1 girl. I think you're not stupid, right? I insulted you multiple times. Yes, I see it. I did insult you. But I think you're not that stupid. You are actually capable of this logic, that one must say, I have at least 1 boy, and here one must say, I have at least 1 girl. So, what happens? We know the probabilities of each elemental outcome compared to the whole pool of outcomes, right? So, well, I forgot to write 25% here too. So, well, that means that all boy-boy pairs are in the bucket at least 1 boy, right? But only 12.5% of the girl-boy pairs and 12.5% of the boy-girl pairs are in this same bucket. So, they have a 1-to-1 distribution, because they are 25%, they are 25%, which means we get 50% to get this pair, right? If you actually tried to think this through yourself, you would see that it's the right way to do it. We have the experiment, flip 2 coins. I have flipped 2 coins, and I get to the conclusion 50%. So, and the same in the other case. So, I explained now that you get to 50% without your false experiment. So, I don't have to use your false experiment to get to 50%. You only use it because you didn't think it through. And that's the thing why I insult you, because you didn't think it through what I said, and you keep repeating yourself all the time that this is the experiment we must use. But it's not. So, and here is a bonus for you. So, try to figure this out with your logic, and it would come to the wrong conclusion. Bonus, what I already said, 3 children and random facts. So, there your logic is false, because there's the one case where the parent has boy, boy, girl, boy, girl, boy, or girl, boy, boy. So, each time we have 3 possible facts that the parent can tell you. They can either tell you, I have at least 1 boy, they can tell you, I have at least 2 boys, or they can tell you, I have at least 1 girl. So, there's nothing else they can tell you which is a true statement and doesn't reveal everything, right? So, these are the 3 possible ways they can split up. So, it's a 1/3 split ratio for the bucket. And for boy, boy, we have only 2 possible facts, because they can say, I have at least 3 boys, because that will reveal everything, and we exclude this possibility. So, they can say, I have at least 1 or I have at least 2 boys, so there is a 1/2 split ratio. So, we get 1/5. Why 1/5? 1/5 is just the distribution of the elemental outcomes. So, ratio of elemental outcome, because we have this 1 possible, those 3, and then we have the 5th one, which is girl, girl, girl. So, 1/5 times 3, because I have 3 different permutations, times 1/3. That's the split ratio. And this equals 1/5. Yes? That's the baggage ratio of them, of the three possible children. Yeah. And now we have 1/5 times 1 times 1/2 for this case. That's the baggage ratio of 3 boys. So what's the chance when a parent tells you randomly, I have at least 2 boys and I have 3 children? What's the chance that the third child is also a boy? Well, we have the amount of our favorable outcomes divided by all possible outcomes, which is this one and this one. So we add them, and this is 3/10, and this is 1/10, and we do the math, and it's 1/3. It's not 50%. And if you actually did this, you would come to the same conclusion. But either you are not qualified for an introductory class in statistics, or you are a troll. And that's why I insulted you, right? Because you didn't think this through, and you just kept repeating that we need a single coin flip, and then with the outcome heads, and then flip another coin. And that's just wrong. That's not even what was stated. Stated was I have 2 children, and not I have 1 child, and then I'm getting another child. How is this so hard to understand?